Hey there. So if you've ever poked around your Bitcoin node using Bitcoin CLI, you already know it's a pretty powerful tool. But today, we're going to take a huge leap forward. We're moving beyond just typing in simple commands. We're going to see how you can actually programmatically talk to your Bitcoin node to build some really cool applications, run complex analysis, and, truly unlock what it can do. And to see why this is so important, let's just start with a challenge that's, well, it's pretty much impossible to solve from the command line alone.
So just think about this for a second. How would you actually calculate the total value of every single transaction packed into one specific Bitcoin block? I mean, you could try doing it by hand with the command line, grabbing one transaction at a time, but seriously, you'd be there all day. This is the perfect example of a problem that shows us exactly where our manual tools just hit a wall. And that's really the heart of the issue, right? A tool like Bitcoin CLI is fantastic for, say, looking up one transaction or just checking the current block count, simple stuff. But for a big question that requires hundreds of steps, like, okay, first get a block, then get every single transaction in it, then look at every output of every one of those transactions and add it all up, well, it just becomes completely impractical. We need a better way.
So to solve problems like this, we've got to go beyond the command line. We need a way to let a program, not a person, do all the heavy lifting and all the talking. And that's where programmatic access comes into play.
That's exactly what an API, or an application programming interface, is for. It's the bridge that lets our code directly call functions on the Bitcoin node. So instead of us sitting there typing commands, our script is doing the talking, which opens up this whole world of automation and really deep data analysis.
So what is this magical bridge that lets our programs talk to Bitcoin Core? It's a specific kind of API called the JSON RPC API. Now I know that sounds like a big mouthful of technical jargon, but trust me, it is way simpler than it sounds once we break it down.
Let's just look at the name itself. JSON, that's just a simple, human-readable text format for data. You've probably seen it before. RPC stands for Remote Procedure Call, which is really just a fancy way of saying our program is calling a function that lives on the remote Bitcoin node. And it does all of this over HTTP. Yeah, the very same protocol your web browser is using right now. So at the end of the day, it's really just sending simple text messages over the web.
The whole interaction is just a simple three-step conversation. Our program wraps up a command into a little JSON message and sends it off. Bitcoin Core gets it, runs the command, and then sends a JSON message right back with the result. Request, process, response. That's it. Every single programmatic interaction boils down to this simple little loop. Okay, enough theory. Let's get our hands dirty and see what this actually looks like in practice. We're going to start with the raw method, using a command line tool called curl. And trust me, seeing the hard way first is going to make us really appreciate how simple the easy way is later on.
Check this out. This is a curl command, which is a tool for making web requests. And this is perfect for showing you what's really going on under the hood. We're literally sending a chunk of JSON data that says, hey, I want to run the method getBlockchainInfo. And we're sending it to our local node at port 8332. This is the raw message our program would send.
But of course, you can't just let any random program on the internet start bossing your Bitcoin node around. For security, any request you send needs to be authenticated. You have to prove you actually have permission to make that call.
So how does it do this? Well, it's actually pretty clever. By default, every single time Bitcoin Core starts up, it generates a long, random password and just saves it in a little file named .cookie right inside its data directory. Any program that wants to talk to the API needs to know how to read this password and send it along with its request.
And if you were to peek inside that file, this is what you'd see. It's designed to be super simple for a program to read. You've got a username, a colon, and then this long randomly generated password. This string right here is our magic key to the API.
So, after we authenticate and send our curl request, we get this back, a giant blob of raw JSON text. And here's the crucial part. All the data we want is in there. You can see the chain, the number of blocks, but it's all buried in this format that's, well, it's tough for both humans and programs to parse. Imagine trying to reliably fish out just one number from all of that mess. Luckily, no developer actually does it the hard way. Building raw web requests like that is tedious, it's error-prone, it's just a pain. So it's time to move on to the smart way, using libraries to do all the heavy lifting for us. So instead of manually building JSON requests and handling authentication and parsing all that messy text, we can use what's called a wrapper library. In our case, we'll use one for Python. Think of these libraries as expert translators. They handle all that complicated background work, so we can just focus on what we actually want to do, which is ask the blockchain questions.
And this right here, this is the magic moment. Look at this. All of that complexity from the curl command, the authentication, the formatting, the raw text parsing, all of it is just handled by the library. It transforms that multi-line, complex command into a single, clean, readable line of code. This is the power of working smarter, not harder.
So now that we've got the right tool for the job, let's go back and finally solve that challenge we started with.
Let's start with a simple Hello World example just to prove our connection works. This script connects to our node and makes the exact same get blockchain info call our curl command did. But just look at the difference in clarity. We're not building a web request anymore, we're just calling a simple, straightforward function.
And when we run it, bam! It cleanly prints out the result, the number of blocks our node has synced. Now, it's a simple result for sure, but it proves our connection works and it shows just how easy the library makes it to get the specific data you're looking for.
Okay, time for the main event. Here is the script that solves our initial challenge. It might look a little more involved, but just follow what it's doing. It gets a block, then it loops through a list of all the transaction IDs in that block. For each ID, it fetches the full transaction. Then it loops through its outputs, adding the value of each one to a running total. Can you imagine doing this by hand? It would have taken hundreds of manual commands.
And after all that looping and adding, our script spits out the answer in seconds. The total value of all outputs in that single block? 10,322 Bitcoin.
So what exactly does this number represent? It's the total value of every single payment that was sent in that block, but it also includes the Coinbase transaction. That's the block reward for the miner and all of the transaction fees combined. It's a complete accounting of all the value that moved in that moment.
And that really brings us to the most important point. The code itself isn't the real lesson here, the power it gives you is. You now have the keys to the kingdom. You can move beyond just observing the blockchain and start actively querying it, analyzing it, and building right on top of it. You could build your own block explorer, a custom wallet, or some data analysis tool that finds patterns nobody has ever seen before. The door is wide open. So the only question left is, what will you build?